understand in terms of how carbon moves. So let's take a look at what we're going to do today. The first thing I want you to do is with your bill in front of you, just kind of watch along with this presentation. And if you feel free to pause it at any time and jot down some of your ideas as well, or some of your answers, just to make sure you're following along. And then at the end, there is a Google Doc that you need to submit for attendance purposes. But this video here is pretty short and should help you with understanding what's going on with some other molecules as well. We start with looking at this particular situation. We have methane, which is commonly used, or also known as natural gas. It's burned at home. A lot of you have a gas stove, and this is sort of the molecule that's there. If we look, the methane molecule is on this particular slide, and we can see it here. And let me get my pen up and running for it. And we can see here that the methane we have a bunch of it right here, all around here. These are all methane molecules that I'm circling, and you can see those. And that's what is part of that flame there. But let's take a look a little bit closer in terms of what's going on as these burn. So this is the bottom of the flame. We got a lot of methane coming into it. And then we have our molecules that are found in air. We have our oxygen and our nitrogen, a little bit of carbon dioxide, not much, and then we have water, and then obviously the methane that I pointed out. How's the top of the flame different? Well, we notice that there's less methane at the top of the flame because a lot of it has been burned up, and that's what we're going to compare. We're going to compare these two things in the next slide. We know at the bottom of the flame we have a lot of this methane, and if we look at our air that's coming into it, we know that oxygen is coming in, and then we know that that's going to be used along with that methane and burned to produce those molecules at the top. But let's take a look at the bottom again. And just if we think about air, we know that there's very little carbon dioxide in air. So we have one CO2 molecule over here. So one CO2 at that bottom of that flame where that methane is just starting to burn. And if we also think about other molecules that could be in our air, we do have some water. We have 1, 2, and it looks like one hiding back there. It looks like 3 waters back there, 3 H2Os. What happens when these things burn? Well, obviously they get to obviously they are released from the flame, but as they burn, we see a change in the air that's at the top of the flame. We now see that there's much more carbon dioxide. There's 1, 2, 3, 4 CO2s at the top. And we also see there's a little bit more water too. So 1, 2, 3, 4, and there's probably one hiding over here. 5, we see 5 water molecules at the top of the flame. So you can see that there's a change there in that system, especially in terms of the air between the bottom and the top. What's the hidden chemical change when methane burns? So how is this chemically changing? And I think we have to understand that when we look at the next slide here. We can see then that the oxygen is combining with that methane and going into the flame, and then released from that is that CO2 and water. Now, you have on your ethanol evaluation, you have to write 3 paragraphs about, how does matter move, how does matter change, and how does energy change. And a lot of times students struggle with providing evidence and understanding how these questions work. So we have some helpful tips here on this slide, and you can use this slide. You can pause it and use it anytime you want, or come back to it if you need to. It's possible I'll try to share this slide too in our Google class so that you can use it as well. But here are some key things to think about. First off, let's look at matter moving. All materials, if we look at rules to follow, are made of atoms. We know that are bonded together in molecules. What are the questions that we can ask about movement? Well, how do molecules move from the location of the chemical change? And how do they move away? So there's a question about how they move to the location. How do they move away? And I think we see that, molecules are moving into the flame. You might have a pressurized gas tank or something like that, and that's how they're moving into the flame. And we know that molecules are being released into the air and into the aquarium, like when we did the demonstration. Well, the big thing is being able to provide evidence. How do we provide evidence? And we know that the big evidence here for that is that change in mass. Okay, can you explain the mass changes that are occurring when you burn ethanol? And so at the home, we know that natural gas is just coming into our house. We're not noticing a change in mass in that. But if you have a propane tank and you live out in the country, that has to be refilled periodically. So a truck has to haul that propane to your house. That's moving matter, and that matter has to be then put into that tank so you can use it. And so that in cases of natural gas, we know there's big suppliers probably in terms of towns, or we have pipelines and things like that that are shipping these fuels to our houses. What about matter change? Well, we know that matter atoms can be rearranged. They last forever, but they are obviously rearranged when the molecules go underneath this chemical change. And so we're looking at how molecules are rearranged. That's kind of the critical thing that you got to be able to explain when you talk about change. Can you explain how the atoms are being switched or changed? Evidence of this, well, obviously BTB can be used for this. That's going to be the big piece of evidence in terms of chemical change. But we also now can use those terms use terms of fuels and foods and things like that to help us understand what kind of material is changing. And all these materials are organic. So we know that they have those CC and CH bonds, which are changing in those molecules. Finally, what is happening to energy? So we want to know what's happening to energy. Is energy changing? And so, well, it obviously is. Energy cannot be created nor destroyed, but it can change. And so we're looking at how that chemical energy, which is over here, how that is changing into that heat and light energy, and possibly motion or other forms. What happens to atoms and energy when methane burns? So let's take a little bit a closer look at this. And this is an overall view here. We have our chemical energy, which is stored in that methane. And then we have our oxygen, which comes from the air. As we see here, we get a rearrangement of atoms. So they're switching places and they're moving to different things and they're going into our products, which you've seen in that ethanol as well. Here on this slide, we're going to focus though on what happens to the carbon atom. We have one carbon atom in ethane. In ethanol, we had two, but in methane, we have one. Where is that single carbon atom going to go? Feel free to pause the video and just jot down. Where would the carbon atom go that's in methane if it burns? Okay, so if you said that that carbon atom ends up in CO2, you are correct. And that's exactly where it goes. It goes into that CO2 molecule. The bonds are broken. It's rearranged to form that. What about oxygen? Where do those atoms go when something burns? As you can see here, those oxygen atoms are going to combine and be rearranged, and some of them go into water and some of them go to CO2. So they actually get moved into two different molecules. Finally, what happens to the hydrogen? We have those CH bonds. We have those hydrogen atoms. Where are they going to end up? You can see those hydrogen atoms end up in that water molecule. And so they were not destroyed. They just end up in water. Finally, what happens to energy? We see these high energy bonds in that methane molecule. When we're able to activate that reaction and provide enough energy to get it going, those bonds are broken and heat and light energy are released. So the bonds are simply moved into a different form of energy. Finally, this slide summarizes what's going on. And as we can see here, shows you everything in terms of what's going on with atoms and energy. Pretty simple. There is a Google Doc in Google Class for you to complete that looks similar to this slide right here, where you have to basically count the atoms that are involved in the reaction of methane burning, and then what happens to those molecules and how they're rearranged and what happens to energy, just as a quick little review to make sure everyone's on the same page. And then again, remember your ethanol evaluation is due tomorrow. So make sure you get your big 3 questions answered and your paragraphs written. And if you need any help with that, be sure to contact me via email. Otherwise, have a great day and go Bulldogs.